Hello everyone and welcome back to my YouTube channel. So I'm Mayank Agarwal and we are learning Python through a Hello Python series. So in the last video we learned about how functions in Python are a first class citizen. So in this video we are going to cover a very important topic in Python, that is Lambda functions. So let's get started. Great everyone, so now let us begin with Lambda functions. So before actually diving into the notes, or I would say definition, first let us understand why the need of Lambda function arises. Okay. So we have seen that, okay, how the functions are first class citizen and how you can pass the function as an argument, right? Or you can even return functions basically from within a function. Now, many times it happens, like let's say you want to just do a quick work on some particular thing, right? Let's say you just want to square a particular list, or let's say apply a already built function on some particular list, right? It can be factorial or it can be your defined function as well, which is very complex. Let's say login or authenticate or something like that. Okay. So now what happened is that we were earlier defining it like this. Okay, we were basically making a square in the memory. Then anytime I want to use a function, anytime I wanted to use a function, what I was doing is, let's say def, so apply on list, I'm just creating a function. So let's say I get a list, then I get a function, then L1, okay, not L1, L2, okay, then for I in L1, L2 dot append func of Li, and I can just return L2 here. Okay, so this is a very, I would say, basic kind of a code which we have written. Now here if you will see, like square we have created, then apply on list we have created. Now let's say if I have to apply, okay, on list something like this, 1 2 3 4 5, and let's say this time I have to apply square, okay, and I'm able to get my answer. But now let's say the requirement changes, and now see, the understanding is that now I will have to find the cube. Okay, so let's say I have to find a cube. Now again I will go and define a cube function, return x, and I can get a cube. Now let's say the requirement again changes and I have to find square root. Now in the real industry sense, it can happen that a very good example is actually something of a convenience fee which these companies charge. Maybe they were charging 2 rupees, then it come to 5, then 6, something like that. The requirement overall keeps on changing, and that is how about something which we have to handle as well. Okay, so if you find the square root, then I can return x star star by 2. Hopefully this will work. Square root. Yeah, I think it should be, it is getting divided. Yeah, now it should work. Cool. So now we are able to see the square root as well. But I hope you are able to see the problem. Like these small things, right? These small very basic kind of a function, I have to always first define them, and I might not be using them a lot, right? Let's say square, cube, square root, I just use it here, and I will not be using it anywhere else in the code, but they are getting permanently defined in my code. Okay, and it can happen that, okay, some other function I have to apply, but which is very transient in nature, like I just apply it there and then, and I don't have to apply it anywhere else. So defining these functions in the memory, okay, and it may happen that tomorrow I'm making some square as some other function and it can basically override this, or some case like this can also happen. And it is actually, I would say, in programming, lots of use cases are there where we have to just maybe make things positive, or I would say apply. So for positive, we can just do absolute, okay, x, and let's say I just return abs of x, right? Something like this. Again, it's gonna find your answer. So again, the overall understanding is the same, right? That this func which I am applying here, right? This I am applying, and I will have to create these functions after every time. So if 4 things I have to apply, I have to create 4 functions like this in the memory, and that is where Lambda functions comes to our rescue. Now it is a lot, I would say, made complex kind of a topic. It is very easy to understand, but I think nobody just people just tell you the syntax and stuff, and nobody explains you the real reason. So intuition and real reason is this. This is the use case. If I want to apply all these 4 functions, why should I create them in the memory when they are very transient, very, I would say, just using them once, okay? Or they are just doing a very easy thing, right? So for that particular use case, Lambda functions are actually done. We have, so they are single line, they are anonymous function, and the keyword lambda is used to define them. So Lambda function, you can just think of, I would say, when you join a company, there are some set of rules, right? Which you have to do, download the code base, maybe get an iCard and all these things. But some are very, I would say, things which are not written, that, okay, this is your seat, or you can just sit anywhere. Or let's say 2 o'clock, maybe someone is calling you for a tea break, something like that, which is very transient in nature. You don't have these rules written, right? Or maybe when you write some to-do list or some sticky notes, right, where you just have to do them. You will just do them and just, I will say, tier them, right? Just using them for the time being. You don't want to define them for the permanent. It is not some rule or some function which you will be needing. Okay, so that is the major use case. Now this is the overall, I would say, properties. It is a single line, small anonymous function, and keyword lambda is used, and generally used to pass an argument in a higher order function. Okay, so this thing is very important. Again, now let's see the overall, I would say, syntax. So we say lambda, we write lambda first, then these are the arguments. So let's say if you're writing square, or let's say not square, let us just remove, yeah, if let's say I'm writing sum ab, then this is where you will write this ab, and let's say if you are returning, so they always return whatever you are doing, they always return that. Okay, and they return a plus b. So this is the expression of working. Now you will see that it is very single line, and yes, the expectation is that you will not be applying a lot of I would say bigger logic or anything in this. If you want to apply a very big logic, something which you will be using, or something which is very complex, please define your own function. That is not a problem. You can always define your own function. But if your use case is very small, then use lambda function and use them to pass in your higher order function. So we can see the same. Just let us go back. So let me just copy the square function, and I'm going to explain you using this thing. So this is how we define a square function. The same function, okay, lambda, I took x is my input, this is the argument, and what I want to return, I can just write here. So this is now my lambda function. Okay, see, it is saying the same as well. Function main lambda x. Okay, now you will have to see this function got created. It is not having any name or anything, but we can have a reference for this particular function. So let's say I just find sq lambda, which is a reference to this function. And now when I do sq lambda here, and let's say I provide 5, it's going to run perfectly fine. In a similar way, let's say if I'm just using the same thing, right? I can use sq lambda and it's going to work fine. But what actually I can also use is, I don't need to even have the reference. I can just create like this, x, okay, x star x, and see, this is working fine. Again, if I want a cube, should be fine, cube. If I want a square root, again, I'm able to get that. If I want an absolute, and I'm able to get that. So whatever it is returning, it is just basically applying. That is what we have seen, okay, each and every element. But the benefit overall is that you are able to basically, I would say, use this directly. You don't have to define this function anywhere. Your higher order function, you can pass this as an argument. Now let us take another example so you understand that. Let's say it is def sum a b. Okay, I return a plus b. So the same thing in lambda will be something like this, a b, and you're returning a plus b. Okay, so sum lambda. Again, it is very easy. Like, I don't know why students get confused in that. Maybe because it is not taught, I would say, in that manner, like the use case manner, building upon the logic. But again, you can just see that, okay, it is very, very straightforward, right? You can even call some other function here. That is going to just give you the answer. Maybe we call the square lambda function here. Okay, if the logic is pretty straightforward, and you will get the answer. But yeah, overall, that's the use case. If you just want to directly use this, what you can do is you write it like this. Okay, so as of now, we were using it with reference. But let's say you want to directly get the answer. What you can do is you can just have it under this thing. And now see, this is your function. So we provide input to this function, and 3 and 5, we can provide the input, and it's going to give you the answer. Okay, so I hope this thing is clear overall, that how and where lambda function is used. So this is the overall use case of lambda function. Now let us see the same. No indentation to worry about. Very good thing, right? We don't have to define them from the starting. No indentation, nothing. Really helpful for minimal use case when we might not want to define full function. Makes sense. I don't want to define a full function. It's a very straightforward, I would say, thing which I want to do with my element, with whatever you are providing me. And I will be doing that. I don't have to actually worry about anything, I would say, by defining the whole function, having that in the memory, then taking care of it like, okay, this function is having this name. Lambda just helps you doing that. And it's just like, as I told, very transient rules, right? So let's say today we are going to do this. You're not going to write it down in your major rule book or something. The company is not going to write it down, right? Maybe let's say today, company, you are not doing any work. That is not going to lift. Like every Friday or every Tuesday, you're not going to do any work. So lambda is basically used in that. That is the, I would say, overall use case in lambda. Now, we can write, I would say, lambda functions for, I think the overall syntax should be clear. Majorly, we will be using it in this way only, apply on list. Okay. And let's say the way we saw this, 1, 2, 3, -5, 6 minus 100. And now instead of just writing anything, I can just do it like this. Absolute of x. See, I'm able to get the answer. Like how easy and straightforward it is. Like anyone, if you know the syntax, you will understand that what exactly is written there. And you will all be good, right? So yeah, that is just the case on which Lambda functions are basically written and used. You are pretty much, I would say, straightforward. You can use them. You understand that how we are actually also using them instead of these functions and what the benefit it is giving, right? Once you code, actually, I would say, and many times it happens that you need these small things, right? So we don't like to define functions for that, right? We are like, yeah, theek hai. If it is a transient thing, let us just have the Lambda function and we will use that, okay? Because I will be able to understand the syntax. It will be created and it will basically be doing what I want for it. So just that is the overall understanding here. Okay, I hope the syntax is also clear, like what exactly are we doing. Now in the next video, we are going to learn about map filter and reduce function. Again, they are very easy function. Like if you have actually seen this and last video, you will not face any problem, but somehow students face a lot of problem in that. So I'm not really sure why. Please make sure that you see this and the last video. I think all the things and everything in Lambda function is done. Yeah, I think these are all the overall, I would say, syntax and stuff which we have to handle in Lambda function. So yeah, great. So cool, everyone. I hope with that the Lambda function is clear. Again, just I would say see the use case of Lambda function. Don't get, I would say, afraid by the overall syntax or something. No, we just write a Lambda word and just define a function. Nothing else we are doing. Okay, that is just the overall use case. Just one more thing which I want to show you is I have actually also then attached another notebook here which will be helpful to you. So Lambda argument expression, similar thing. It just explain you. Okay, so this filter map function we are going to read, so don't have to worry on that. Okay, but yeah, just go through this overall and you will be at a very, I would say, good place to understand things, and yeah, it should be fine. Great. So yeah, everyone, with that, I hope the Lambda function and overall use case is clear. Again, because we are building on our knowledge of higher order function, this will be a lot helpful. This is a lot quicker to understand. The same thing is going to happen with map filter and reduce function in the next video. Please like the video and comment if any doubt is there. And yeah, please share this with your friends and subscribe and hit that bell icon. And I will see you in the next video. Thank you.